the most recent international standard on database, which is GQL, and that was released last year, mid last year. And I think it's going to be a pretty good trigger or kick to the entire market. Basically, giving the market confidence that now we have international standard and all the vendors are going to proactively adopt this standard. So the customer, especially the IT department from those customers, they will be more willing to learn the new standard because they understand all the entire market is going to be aligned or going to be very much compliant with the newer standard. So that's really going to accelerate things. It probably takes 1 to 2 years. So maybe next year going to be a prime time, the beginning of a prime time for broader spectrum, adoption of graph technologies.
Welcome to Graph Geeks in Discussion. I'm Amy Hodler. Today, I'm sitting down with Ricky Sun, a leader in the graph space and the founder and CEO of Ultipa, a high-performance graph platform. And we're going to talk about a little bit about the graph market itself, but also about the ISO standard query language, GQL or GQL, depending on your preferred pronunciation. So welcome, Ricky. Wonderful to have you here.
Well, good morning. Thank you, Amy. Pleasure to be here.
So, Ricky, for those that don't know you yet, can you tell us just a little bit about how you came to be in the graph space in the first place?
Totally. So, well, it's a long story, but anyhow, this is like how much time we have. So we're going to make the long story short. So officially, we launched Ultipa about 6.5 years ago. So Ultipa is about like 6-7 years old company, startup. Long before we launched Ultipa, I think that was like back in early 21st century, like that was almost even before the internet bubble burst. I think one day I was driving on highway, I think that's highway 880 northbound, heading to the office. I heard like people from NPR, National Public Radio, talking about, is there a way to be able to conduct causality search? Like they were basically talking about there are so much information, so much knowledge in this universe. Is there a way to identify the connectivities between any two entities? And they were giving an example somehow that was really fascinating. The example was talking about the connectivities or the path or the causal path between Isaac Newton and Genghis Khan. Like these are the two very much famous people from the Western world and the Eastern world, how they are connected. So by that time, it was still very early stage. Out of hunch, we thought there got to be a way to find, the causal path. But before we started Ultipa, there was another startup that I was part of the co-founders. And we were basically ingesting information from Wikipedia dataset. And remember, Wikipedia has all kind of articles, and the articles are basically connected with each other via the hyperlinks. So those will be the relationships. Then the articles, basically a bunch of nouns, entities. This has a potential to build a large-scale network so that we can conduct network analytics. Now we're getting to the detail. I mean, a little bit technical detail, but very fascinating. Like I think back in 2018, we were able to ingest those data in a graph computing engine. It's an in-memory graph computing engine. And we were trying to do the shortest path to simulate the causal, search across the entire Wikipedia entities and all the hyperlinks. Then we found something really, really interesting, like that Genghis Khan started the Mongol invasion to West Asia and Europe. And all the historians agree that this Mongol invasion really triggered Black Death. now we see how things are developing, right? So the last major outbreak of the Black Death across Europe lasted was lasted a couple centuries, 3 centuries, 3 to 4 centuries, and the last major outbreak was the Great Plague of London. Now take a note. This is very close to where the time-space continuum, like where Isaac Newton was living back in the late 17th century while he was attending Trinity College, and basically all the schools were shut down, and he went back to his hometown, and his head was like hit by the apple. So that is exactly the causality search we were looking for, and then the start of Ultipa was really, can we find a way to do this kind of search always in real time? Which means we can, we can build an engine and also website, which is a web portal or web services, so that users can search connectivities among any entities. And that is the beginning of Ultipa. But, yeah. So, Amy, this is a long introduction, but hopefully this triggers some thinking,
Yeah, and actually, I'm giggling a little bit because one of my favorite TV shows as a child was the show Connections, which was a British TV series. And I'll just say it must have been in repeat because I believe it was more in the 80s as well that I was watching. But this idea of like long tail connections and the implication is something that's fascinated me since a child. And I am also a big fan of causal graphs as well, which is a whole other discipline that we don't have to get into here. But I think there's a common thread there of people who are interested in highly complex and interesting problems, not the what, but the why problems are drawn to graphs. And I think companies that need to solve complex problems end up in graphs because understanding that causality and the long connections is just hard to do in tables. But I do have a quick question for you before
Sure.
we move on to talking about like the graph market in general. What what is the thought behind the name Ultipa? Because I've always been trying to find the meaning in the name of the company, but you just shared with me previously how that came about. So yeah, can you share that with the audience?
Yeah, we want to we want to find a company with a name uh, that can be quite unique, and also it manifests exactly what we are trying to achieve. So Ultipa is a made-up word. It's like 6 characters. It really stands for ultimate processing acceleration. So
Nice.
that is our ambition even from day one.
Got it.
Ultimate Ultipa. Yeah, that's the beginning,
Nice.
right?
Well, it definitely rolls off the tongue. And it's easy to spell, which I always like in names. But we were going to spend a little bit of time talking a little bit about the graph market because it is in one way changing and another way not changing. There's just a lot going on in this space. So what's your read on the graph database market right now?
Right. I mean, this is a tough market because remember, you just mentioned, Amy, people are drawn or coming over to the graph market because they understand they are looking to graph to really solve difficult, complex problems. So that's exactly the challenges here. I mean, uh, broadly speaking, uh, most of today's IT infrastructure are basically relational centric or table centric. So, which is a lower or low dimensional way, to represent, to model after the real world problems. And graph, clearly, well, we always say, graph is high dimensional. However, the number one challenge, I mean, 99% of the customers, they were pretty much, feel frustrated is how to do graph data modeling. Even they have all of those existing data in their data warehouses, in all kinds of systems, all kinds of siloed systems, all kinds of tables, but they don't know how exactly to build a connected view or connected network. Essentially, I think the number one thing is to do graph data modeling. Once you have graph data modeling, then the rest of the problems are pretty much can be streamlined, meaning you can start conducting, given the graph model, you can start conducting graph analysis, graph queries, running graph algorithm. Then basically the results can be further graphically visualized. And so then that makes it end-to-end, solution. But I think so far the market uh, is not full of solutions. I mean, a lot of companies, even a lot of graph database vendors like us,
Mhm.
we couldn't serve all the customers who are looking, to find a perfect solution. And Ultipa is startup, we are much smaller than Neo4j, even though we have created some very interesting trailblazing use cases. But I think we still have a long way to go.
Mm.
So if you look at this, Neo4j is an almost 20-year-old company, right? They have about 1,000 people. But compared to Oracle is a 50 years old company. With over 10,000, 100,000 people. So I
Mhm.
think Graph still has a long way to go. And we haven't really seen, no, not seen, we foresee like Graph going to be the future. There's no doubt about it. But I mean, the entry barrier, the hurdles and the problems we're going to address down the road, we probably still need a couple more years to see really, major companies, growing out of the startups today we are
Well,
working in.
so you said something interesting in there. You use the word applications or solutions, I think solutions perhaps. And one of the things that I've noticed the last maybe year or so is graphs, I want to say, going under the hood. In other words, I'm seeing some startups founded that aren't selling a graph solution. It's just they're using graph for their application or for their solution. So they're using a graph foundation to then do some other services. There's an interesting satellite imagery company that does that approach. There's a user product management, user feedback application as well. That's really interesting, where it's taking in notes from user dialogues, so product managers can know what to do in their next roadmap. There's all sorts of these little companies out there, and that always makes me happy because the more people are using graphs for different solutions, as you said, not there's no one vendor or even 10 vendors that can service everything.
Right.
um, that makes a lot of sense for me that you would just use graph under the hood like you would any other database or data platform. But we're not awash in graph applications right now. We're not awash in graph solutions yet. Why do you think that is? If it makes sense under the hood, why aren't we seeing more proliferation of graph apps, so to speak?
So now this is an interesting topic. I think there are different perspectives, when we look at the market today. Uh, I think before GQL, before GCO was publicized, basically. So the most recent international standard on database, which is GQL, and that was released last year, mid last year. And I think it's going to be a pretty good trigger or kick to the entire market. Basically, giving the market confidence that now we have international standard and all the vendors are going to proactively adopt this standard. So the customer, especially the IT department from those customers, uh, they will be more willing to learn the new standard because they understand all the entire market is going to be aligned or
Mhm.
going to be very much compliant with the newer standard. So that's really going to accelerate things. It probably takes 1 to 2 years. So maybe next year going to be a prime time, the beginning of a prime time for broader spectrum, adoption of graph technologies. And the
So,
other, like
oh,
the other perspective is really about there are different, kind of like cutting points. Like for instance, we are graph database vendors, so we tend to empower the customer using starting from the foundation, right, which is the graph database. And on top of the graph database, we expose different kind of API and SDKs, allow the customer or third party or our partners or ourselves to build end-to-end solutions. But there are a lot more lightweight approach. Basically, they are hoping, to be underpinning graph database ignorant or agnostic. Then they start building knowledge graph sort of applications, basically calling, the underpinning graph databases. And that's another way, which is a lightweight way to, to approach how to build applications. There are many other, I think, issues really, like we talk about how difficult it is for the customers or for the vendors or even for the third-party partners to really conducting the graph data modeling. I think that's the most challenging part. So today, I think up until today, we don't see a major, uh, like, what I'm trying to say, we don't see major consulting companies like, like Accenture, EY, uh, KPMG, Price Waterhouse. These major consulting companies, they have all kinds of solutions built on top of the SQL and the relational database. But they probably, like EY is a major partner with Neo4j, but we don't see EY building graph-based solutions everywhere. So they are not full-blown yet. And that's going to take some time.
So the other thing is we've been talking a little bit about or dropping in references to GQL or GQL. There's a whole conversation in naming itself. But yeah, can you talk a little bit about what GQL is and your involvement in that? Because I know your team has actually put a lot of work in supporting it and fully supporting it. So let's take a moment and just to kind of explain what that means for people that aren't as familiar.
Totally. I think the beginning of GQL was well before the pandemic. That was back in 2017 to 2018. Especially, I think the major heavy lifting work was started from 2019 to 2024. Things were a little bit slow during the pandemic because remember globally, I think things fallen apart for 3 years, 2020 to 2022. So, but finally, we have a standard. I think from day one, most of these people understand we need something else. We need something high dimensional. We need to build something that we can't see SQL will be extended to support. Because remember, SQL has a work committee, and they are trying to support graph. And this is like parallel to the GQL committee. But I think at the end of it, a lot of people believe, we need something else. It's not only at the very beginning, GQL was thought to be complementary to SQL. Now, if you read the standard of GQL, I think it's very much standalone, and it has a potential to be somehow backward compatible, but also carry a lot of hopes, to be able to allow people to conduct like causality search, which like path, all kinds of path search. So which are uniquely different from the SQL world. So, and Ultipa was involved in the standardization of GQL in different perspectives. Because remember, there's a GDC, formerly called LDBC. These guys, we were part of that, LDBC committee, and we were building, for instance, at the very beginning, LDBC was very much focusing on social network benchmark for graph vendors. But that is not enough. I think Ultipa was the first company came in, that was like over 3 years ago, telling LDBC committee that social is not the only, not even the most typical way, in the industry. because a lot of financial companies, regulators, government agencies, they are actually using financial transactional data. And this is hugely different from the social data. So let's also create a financial benchmark. So that's our focus for the past like 3 years. And once we have the financial benchmark released since last year, now I think we are really covering you know broad spectrum of the market in terms of what kind of data should be considered graph data. Because previously they were looking at social data, but now they're also looking at financial data, and there could be also supply chain data. But supply chain data can be considered a unique a subcategory of the financial data because financial can be very broad, also including all the business related data and also supply chain related data. Yes.
It's kind of funny you say that because if you're at all familiar with network science, anything that's a system is pretty much graphy data. It's, anything that's connected, whether we're talking about biology, financial transaction, traffic data, is connected. So anything that's system wide, that has a system operating, to me, that's connected data is relevant. Uh, so just for listeners, GQL or GQL,
Mhm.
as Ricky, you help me understand. People say GQL when they're comparing to SQL, and they say GQL if they're talking about the standard as graph query language. So they're kind of pronouncing that out, and having it definitely makes sense. We're having a standard for such a different type of query
Yeah.
is just going to help everybody, develop applications, school tools, skill sets. Investing in your own career. If it's a standard, it's easier to then, use that later. Uh, do you thinking about the push for the GQL standard and the standard that was developed, which was a significant milestone? Does that impact at all existing proprietary languages or languages like Cypher and like the overall graph landscape itself? Like, how does developing a standard actually impact that landscape?
Yeah. So I think on the one hand, uh, since the GQL standard was released, it's actually it's easier to convince the customer that they're gonna if they are adopting a graph database and the graph database happens to be speaking the future standard, which is the GQL, the customer will feel a lot more comfortable. Previously, you're going to have to take a long time to debate, even to convince the customer that, oh, you know, our company will never die, but, they never believe in you because you are not speaking international standard. And what if we procure your graph database for 10 years or 5 years, and after 3 years, you're gone? What are we going to do? So then if it's an international standard, then it's going to be much easier, like they know that the other vendors potentially so they can avoid vendor lock-in, even the language lock-in, from certain perspective. Right. So I think that is the really one of the major advantage or benefits of having a GQL international standard.
So, and that makes a lot of sense. We were talking about use cases a moment ago. Do you feel like there are certain use cases or problems where GQL or GQL, regardless of what's underneath it, will be the way to query, and certain types of problems where it will always be SQL, so that you'll have like maybe you'll have developers that use both, and it depends on the problem. Are there? Yeah, what do you see in regards to use cases?
I think in the next 5 to 10 years, people are, I mean, there are over 20 million SQL developers, and
Yeah.
probably only, 10,000 or 20,000 SQL developers today. Very early stage, no comparison in terms of the user base. So in the next, like maybe 5 to 10 years, these developers gonna use both. I foresee them using both. So there are like aggregation, filtering, SQL are still very, like against the tables. SQL is still very effective. Uh, but in terms of network analytics, GQL going to be more effective. But the interesting we see is that different vendor will have different kind of implementations. So the underpinning implementations will be different in terms of performance. Even the language, the GQL language will be the same, but the performance can be hugely different. In terms of the design, because this is a standard, it's more like a framework, and our specific implementation can be hugely, variant. So my understanding is, like for instance, like we have a SQL standard. Now we have Oracle's PL SQL, and in many cases, PL SQL is far more competitive or faster than MySQL's implementation. You know, like we feel we see the same thing, but we are still trying to catch up. For instance, Ultipa, we have a UQL, Ultipa query language, and in many cases, UQL is 10 to even 100 times faster than the GQL implementation. So now what we are doing is that we're trying to catch up. We're trying to optimize, the parser, the analyzer, whatever, the profiler. We're trying to make sure the GQL implementation can be equally competitive. But it takes time. Takes time.
So, how would you recommend somebody that wanted to upskill or get started in understanding and incorporating GQL in their, in their school, in their skill set, or look at implementing, something using it? How should they get started? Is there some resources you can recommend?
Absolutely. So, Amy, this is my only advertisement for today. So this is my new book. I wrote with my co-authors, my colleagues, Jason and Yuri. So now I think this is the first. This is the first book covering the international standard of GQL. So it's called Getting Started with the GQL. And so we wrote the book basically to help promote the standard, the language, and also to help the industry to understand how exactly you can get started. Exactly, as the name of the book. And we also offer a free GQL playground. So basically, the readers can practice all the GQL queries within that playground. It's kind of like a stripped down edition, the cloud native edition of a graph database, and which is standard speaking, GQL speaking. Yeah.
Okay. Wonderful. Well, thank you for doing that for the community. For those listening, I will put it in the description. I'll put some links in the description text. And it's nice to see because I don't feel like there is any de facto leader yet in GQL implementations. And so it's really nice to see Ultipa taking that, the stance of, hey, we're gonna help people get started. That's always really appreciated. And I think at this point I will kind of move direction a little, and because of the AI moment that we are in, that I have to ask you about graphs and AI. Otherwise, I don't know, I wouldn't feel up to date. But of course, graphs and graph rag, really popular. Everyone's been talking about it. Have we hit a ceiling on it? Is there other things that you see?
You talk about how graph and AI potentially can be integrated. And like, I think over the past couple of years, especially with the rise of large language models, like all the customers are asking us how your graph solutions potentially integrate and leverage AI. And so what they really mean, because this is a very popular question global wise, but when you are talking with customers, especially from Europe and also from the US, from the States, the business department, they do have holdback or they do have concerns. They were basically seeing, because over the past 20 years, they have seen the integration of big data and also machine learning, like before the AI was all called machine learning or deep learning stuff. And they were joking about the dilemma which they call GIGO, right? Garbage in, garbage out. So the big data system, they ingest all kinds of data. They collected all kinds of data. They're doing all kind of a probability-based prediction. And a lot of, I think, business department people are thinking, or their daily operational experience with that, it's a joke. It's a garbage in, garbage out kind of stuff. And they don't see much improvement. Now, when we are talking about how exactly we can have graph and AI integrate and augment each other, hopefully mutually, this is what I summarized. I think we carefully and consciously integrate AI. We want AI to handle the first mile and also the last mile. But in the middle, the rest of the 98 miles, we want graph to consciously make, real-time, white box, explainable decision making, or we do white box reasoning or white box inferencing. Let me explain this. So the first mile integration really means we know a lot of the AI today, especially LLMs, are pretty good at handling general purpose data. That's different kind of data sets. We can train these AI models to be able to extract data. Basically, you want, giving your data structured or unstructured, you want to create, remember I mentioned graph data modeling. You want AI to help human beings quickly and smartly create not high, I mean, it should be really highly reliable data in terms of graph data modeling. And the last mile integration really means you can use AI to generate reporting in terms of risk and compliance. But in the middle, like when you are trying to do decision making or insights gaining, be very careful not to solely rely on AI. A graph rag is one way, but in our opinion, like we have seen like in different kind of scenarios, for instance, like smart auditing, decision making, which means real-time anti-fraud, something like that, or basically conducting, causality search or conducting attribution analysis, root cause analysis, using graph can make sure the results is not only explainable, also real time. Like this is the beauty of a high performance graph computing. And also you were not able to do the same in terms of depth. You will be able to deeply penetrate the data set using only graph technology, not the other technology, which the other technology is going to take you much longer time, much more resources, which means higher TCO and lower ROI. So that's our, understanding today. I think that's going to be the future. Of course, um, specifically speaking, you're going to run into a lot of people concerned raising questions that now we are procuring vector database. Do we still need graph database? This is an interesting question. So my understanding, vector database is not a real database. It's a subset of graph database. It should be, all the functionalities provided by all the vector database should be provided by graph database as a bunch of, as a sub features. So that's our understanding. Yeah.
It, it's really an interesting time in I am seeing in talking to people and their implementations this recognition that you have the best tool for the job at hand, and that is not one tool for one job anymore. It's different tools for different steps in the workflow. And so using, as you said, AI at the right spot, probabilistic methods when it makes sense, deterministic methods when it makes sense. And you can't just use just one method. I am a fan of vector storage as well, but the idea of it coming together with a graph also makes sense to me, whether it's a vector vendor adding in graph or a graph vendor, adding in vector. That makes sense. They seem to go really well together, especially when you need
Yes.
probabilistic fuzzy matches alongside more deterministic causal matches. So you might need both, and being able to bring them together just makes a lot of sense. So I'm pretty excited to see that develop, and I'm glad that Ultipa is looking at that as well. So since
Yeah.
we're talking about the future, if we look out, I don't know, let's say 2 years from now, uh, Is there certain challenges that you feel like are going to be addressed in those couple years, regardless of whether it's necessary your company or something out there that might do that?
Right, Amy, this is an interesting question. I think, our approach going to be somehow, we were like, even though we are focusing on building the foundational technologies, I mean, the graph database systems, but we understand most of the customers, when they procure, they basically procure from the application layer, right? Like they procure anti-money laundering system, they procure risk and compliance system, they procure knowledge graph, which is still on the application layer, or according to Palantir, it's ontology stuff. But Palantir is a very tricky company. They don't mention much about their foundation. I think on their application framework, on the foundation, they were building some sort of like a graph database, even though they never call it a graph database, right? It could be open source based. It's not native, but doesn't matter. I think they are addressing customers' pain points, like they are building solutions. So for us, like I think we are serving customers today and also in the next couple of years. Basically, we are building POCs or end-to-end applications. And the applications were all running bundled with our graph databases. So I think this is a interesting way or easier for a customer to accept. Now they have application, they have their solution, and they don't worry too much about there is an underpinning graph database. Sometimes selling graph database alone is a very difficult sell, because the enterprise procurement, so the IT department, they don't want to manage yet another database. So that's a real challenge, right? So but then we don't call this graph database. This could be just called a graph computing engine or graph libraries. Then we're selling applications. But eventually, I think at the end of the day, it's still graph running, all the not fancy, I mean, all the interesting solutions powered with graph computing technologies.
uh, I have to laugh because I've been there with you on trying to sell a new graph technology, especially when it comes with a lot of infrastructure. Is a challenge, and so if I hear you correctly, in the future, in the next couple of years, we're going to be seeing graph solutions and graph applications gaining traction,
Yes.
and whatever's under the hood is either provided as a service or is just obfuscated so the customer doesn't have to manage the infrastructure bits. Um, so to wrap things up for people listening, I got out of this conversation, which was really helpful, that if somebody is interested in a high performance cloud native graph solutions that are also based on an ISO standard, that's where Ultipa shines. Are there other things about Ultipa that you want to convey to people in case they're looking for and trying to understand the difference between different types of graph solutions?
Right. So I think one of the unique things we built in terms of our capabilities, that from day one we were focusing very much on real time is. Let me explain this, because I think all those internet companies, from 20 years ago when they were started building like a Google's file systems, and also Google's banner, and also Yahoo's, they contributed to the Apache Hadoop, and later it's called Apache Spark, and now we have the Databricks, which are very dominating, and even including snowflakes. But the problem is, what from day one we started serving our major enterprise customers. They were basically from the TP world, transactional processing world,
Okay.
even though they are looking to AP solution, analytical processing solutions. But and when we were started 6 years ago, there was Janus Graph, which is the open source graph database. There was Neo4j, community edition or enterprise edition. this solution, these existing well-known solutions were not focusing on allowing TP and AP to be unified, which
I see.
means
Yeah.
the data will be ingested in real time. And also your analytics need to be conducted also in real time. This is a real challenge. What really means is the data need to be streamed into or ingested into the graph systems in real time.
Mm.
And also you need to be able to deeply penetrate the data in real time. So I think the other databases before Ultipa, they were not real-time oriented. They do not support online data ingestion, real-time data refreshing, because their infrastructure doesn't support it. Trust
Mm.
me, most of the big data frameworks like Hadoop, Spark, they don't do real-time anyways, not even today.
It-
So yeah, what I'm saying is that we design our infrastructure to be able to handle this kind of real-time needs from day one. It's
okay.
totally different from the existing or traditional architectures. Yeah,
Yeah, there may be another conversation to be had in that area, maybe a how-to or something, because real-time graph analytics is extremely difficult, for anybody who's listening who has not tried to do that before. Graph analytics can be very computationally heavy
yes,
because you're trying to understand and touch the entire graph in order to understand the shape, the topology of it. And so that adds just a lot of overhead in traditional systems not intended for that, tend to just be very slow, or you can't actually complete the analysis. So I realize that we've been talking for a little while. I would love to go deep into the real time analytics piece, but I'm thinking another session on that would be
yeah.
so much fun because it's an area I love. But we'll probably have to leave it there for now. Thank you, Ricky, for your time and spending the time with the Graph Geeks community. Really appreciate your support and involvement.
Thank you for having me, Amy.